Hello everyone, welcome to 3 Deviations. In today's video, we are going to be covering a little bit of review of differentiation. So before we move off into Unit 4 and to leave derivatives behind for a little bit, I think it's wise that we might look back at some of the rules that we're going to need to remember. So for those of you who are feeling super stable on differentiation, you might want to skip this video and head right off into Unit 4. But for those of you who might forget some of these rules, I would recommend this video as a reference to review some of your rules that are going to be very, very, very important later on in single variable and multivariable calculus. So let's get started with a little bit of review of differentiation. So the formal definition, as you can remember, I think this was probably one of the earlier videos that we made. We could define the derivative of a function f as the limit as h approaches 0 of f of x plus h minus f of x over h. And this is a form of the difference quotient, of course, kind of like that secant line approximation that we see in the upper right here. And then we can make that more of a tangent line to an exact tangent line as we take that limit to 0, and that will give us a perfect tangent line, which gives us many nice applications that we have exploited in Unit 3 with the applications of differentiation. So now that we know the formal definition, we can start making the taking of a derivative less cumbersome. We remember using this formula in Lesson 5, and that was quite cumbersome. So we used some rules. So we took some elementary rules first. One of these rules said that the derivative of a constant term is 0, right? So those constant terms are killed when we differentiate them. Furthermore, if I just have a variable on its own, that's going to be reduced to 1. And if I want to take the derivative of a constant times a function, that is equal to the constant times the derivative of the function. So those were helpful rules, and then one of the most helpful rules, I think one of the most useful rules that we've used in single variable calculus has been the power rule. And that said that the derivative of a variable raised to a power n, the derivative of that is equal to n times x to the n minus 1 power. And that was very helpful for us. And then we also had the rule saying that if I want to take the derivatives of the sums or differences of functions, I can split those up and take the derivative of each function and then do the addition or subtraction operation later. So these are really the rules that we need to remember, although there are some more that we're definitely going to want to know. But these are the ones that we absolutely must remember. Now we also have a grouping of, I call them main rules. These are the rules that we might not use as much as the power rule, say, but we definitely will use a lot of. So one of these rules is the product rule. This says that if I want to take the derivative of f of x times g of x, that is going to be equal to the derivative of the function f times the function g plus the function f times the derivative of the function g. And of course, we had a rule that dealt with the quotients. So if I wanted to take the derivative of a function f over a function g, that's going to be equal to the function g times the derivative of the function f minus the function f minus the derivative of the function g over the function g squared. Now that is the quotient rule. I always remember the quotient rule being a little bit hard to remember. So we have some mnemonics for that. One I like is low d high minus high d low over low low. Now we have the chain rule. This is another important one that we use. So if I want to take the derivative of f of g of x, that's going to be equal to f prime of g of x times g prime of x, right? And of course, the product rule and the chain rule can be expanded to more functions, right? And in certain cases, we can do that with the quotient rule as well if we do some manipulation. All right, so now the next section that we're going to cover is the trig derivatives. So we have a lot of trig derivatives to get through. So we're going to start with the basics, right? So we've got the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of tangent is secant squared, the derivative of cosecant is negative cotangent cosecant. The derivative of secant is tangent secant, and the derivative of cotangent is negative cosecant squared. Of course, we remember this. Also, the hyperbolic inverse trigonometric functions. And these are used a little bit less, but they're going to be helpful in a few units when we're dealing with some harder problems. And we're going to need to remember some of the derivatives. I'm just going to put them all up here at once. And they might be a little bit hard to read, but hopefully I can read them out. So, the derivative of hyperbolic sine is hyperbolic cosine. The derivative of hyperbolic cosine is hyperbolic sine. The derivative of hyperbolic tangent is hyperbolic secant squared. The derivative of hyperbolic cosecant is negative hyperbolic cosecant times hyperbolic cotangent. The derivative of hyperbolic secant is negative hyperbolic secant times hyperbolic tangent. The derivative of the hyperbolic cotangent is the negative hyperbolic cosecant squared. And now we also have the inverse hyperbolic functions, which we will differentiate now. So we have the derivative of hyperbolic sine inverse is equal to 1 over the square root of 1 plus x squared. The derivative of the hyperbolic cosine of x is equal to 1 over the square root of x squared minus 1. The derivative of hyperbolic tangent inverse is equal to 1 over 1 minus x squared. The derivative of hyperbolic cosecant inverse is equal to negative 1 over the absolute value of x times the square root of 1 plus x squared. The derivative of the hyperbolic secant inverse is equal to negative 1 over x times the square root of 1 minus x squared. And finally, the derivative of the hyperbolic cotangent inverse is equal to 1 over 1 minus x squared. All right, so that is a mouthful, and I hope that I read those off right, but those are the hyperbolic derivatives. So the ones that I think we should remember are the sines, tangents, and secants. I always like to remember those. Those are always usually the ones that come back later in calculus. Of course, we want to remember those as well down here. So those are the really important ones for hyperbolic. All right, so now we also have the inverse trigonometric derivatives. So if I want to take the derivative of sine inverse of x, that is going to be 1 over the square root of 1 minus x squared. The derivative of the inverse cosine of x is going to be equal to negative 1 over the square root of 1 minus x squared. The derivative of the inverse tangent of x is equal to 1 over 1 plus x squared. The derivative of the inverse cosecant of x is equal to 1 over x times the square root of x squared minus 1. The derivative of the inverse secant of x is equal to 1 over x times the square root of x squared minus 1. And finally, the derivative of the cotangent inverse of x is equal to negative 1 over 1 plus x squared. Similar to what I said about the hyperbolic functions, I think the most important ones to remember here are sine inverse, tangent inverse, and secant inverse. All right, we're almost done with the review. We just have one more thing to cover, and that is the derivatives of the exponential and logarithmic functions. We remember taking the derivative of e to the x was one of the easiest things possible. It's just e to the x, right? And then if I want to take the derivative of a general exponential, so if I want to take the derivative of b to the x, that's going to be equal to b to the x times the natural log of b. Then if I want to take the derivative of the natural log of x, that's just going to be 1 over x. And if I do that with a function u, then that's just going to be 1 over u times du dx. All right, and finally, if I want to take the derivative of a general logarithm, log base b of x, that's going to be equal to 1 over x times the natural log of b. So I hope that this video was helpful in kind of a departure from differentiation, so we hopefully remembered what each of these were. If not, maybe do a little bit more review, just because this stuff is not going away and we will be dealing with it later. So in the next video, we are going to be introducing integral calculus, and we're super excited about that to begin Unit 4 next time. Thank you.